Hello, today I'll be doing a Python exercise for finding all the prime factors of a number. So here's a problem. We'll write a function to find out the prime factors of a number. Example, prime factors of 84 is 2, 2, 3, 7. So this is a list, so I have to output the result as a list of prime factors. So let's start. So before I go into the coding, here's the plans. First, I will be building the simple version of the function to show the algorithm and steps of getting to the result. And after that, I will explain the algorithm and the key steps where some tricks were used. And then I will optimize this initial function to reduce the time complexity of the function. All right, so let's keep moving. The function takes a single argument called the number. Let's define an empty list which will hold the all the prime factors of the given number. And I will be starting with the smallest prime factors and incrementally increasing that small prime factor to check for primality and if they are the factors of the given number. So my first prime number is 2. So by convention, 1 is not considered a prime number. So the first prime number in the number series is number 2. So let's start the while loop. While less equal to, and I will come to this explanation later that why I am using the math.square root. It's a very widely known and commonly used optimization strategy for finding the prime numbers or prime factors of a number, that I have to check to the maximum number of math.square root. I do not need to check all the way to the number. So let's go ahead. So the first while loop will keep it within the math.square root, and the next while loop will check that if it's a factor, the prime number is a factor. So modulus prime number equals 0. So if it's perfectly divides, the first prime number perfectly divides a given number, then that's a factor. So I have to add it to the empty list, which I created before. Int prime number. And now I will readjust a number, give an initial number, because number equal to, let's do this, prime number, sorry, prime number. And now I need to check the next prime number, so I'm increasing it by 1 plus equal to 1. Okay, so that will run my 2 while loops, and now I will be left over with the number. So let's see, while, okay, if the number is still greater than 1, sorry, still greater than 1, then that means it's a final prime number. So prime factors dot and finally I have to return the final list of prime factors. Okay, now let's test the function. Get prime factor. factors 84. This should give me 2237 as a list. I made a small mistake here, which is here plus equal to 1. Okay. Yeah, so 2237 is the output I got. And now I just want to explain the steps that I took here. So so let's go to another file where I've already put all the explanations. So the algorithm here starts with the divisor to be the smallest prime number, which is 2, and then divide by 2 as many times as I can until I can no longer divide by 2. And during this process, record the number of times I can successfully divide. So if I can divide by 3 2s, then 3 2 will become part of my list of prime factors. And so a few more words on why I'm dividing or adjusting the initial number in the above. That is this step that after I get each of the prime factors, then I'm adjusting the number by dividing it with the previous factor that I have got. And that's because of this reason, that say if I do not divide, the then prime factors with greater than 1 multiplicity will result in the larger factor being non-prime, and I do not want to consider those larger non-prime. For example, say I have already received 2 and 3 as prime numbers, and if I do not divide, the next time I will get 2 into n or 3 into n as my factors, but they are obviously not primes, so I am dividing the numbers. And then also the next step is, so with each successive while loop, I am dividing the number by successively larger primes until I find the one that is a factor of the prime. And okay, but now I will improve this function, because this function can definitely be improved. I do not need to run the loop for each of the numbers in the entire range. That is when I'm giving 84. In this case, I'm just incrementing the prime number for testing the next prime factors by a single one. This is not the optimal way, because I can skip at least one number with a slightly improved version. So let's see that how I can improve it. Let's create a new file first. Prime factors optimized. Okay. All right, so on the right side is my the code that I just did, which is a suboptimal version, and on the left will be my new improvised version. So let's start. So here what I will mainly do is, first I will run in the previous version I have run all the loops in a single while loop, but here I will divide this while loop first to run only for the number 2. That is, I first will determine all the 2's that are factors of the given number. So let's do that. Modulus 0. Always making this mistake of putting this s here. Prime and b 1 is divided by 2. Yeah, so the logic here is when the number is divided, perfectly divided by 2, then I'm appending 2 as its prime factors to my this list here, which is resultant prime factors, and then updating the number for the next run of the while loop. Number equal to number by 2. This is pretty much what it was doing with this syntax. I could use the alternative syntax as well. And okay, so after this while loop is run completely, then I will be that means that all the 2's that were factor of this number has already been taken care of. There is no more 2 left, because if it was more 2 left as its factors, then this particular number could be divided perfectly another time with this while loop. So after the above while loop, I'll be left with only an odd number. Yeah, so now because for my next run of the loop, I will start with 3 and I can skip. I do not have to check each incremental value of the number. I can skip by 1. So let's see how it works. Okay, now I'll be using a for in loop with a range function. For I in range, the starting number will be 3 because I have already taken care of all the 2's that was there in the number as a factor. 3 and int. And again, it is the same thing that I will be checking only till the square root of this number, because of the principle that we just discussed, that for finding the prime numbers, you do not need to check all the way up to this number. I can check up to the square root of this number. So int math.sqrt here, and I should increment this number by 1, and the step is 2. See, I'm including a step of 2, that is I'm starting with 3 and I'm not checking the next number, which will be an even number greater than 2. Obviously that is not a prime number, so I need to get the next odd number after 3. So that I can do with this step of 2, that is first it will check number 3 and then my function will check number 5 and then 7 and then 9 and so on and so forth. Number modulus I equal to 0. Factors will depend I, and then update the number equal to just like here. I have to adjust the next. I have to adjust this number for the next run of the loop by doing number by I. All right, so this should take care of all the 2's and as a prime factors and all, and then other prime factors after 2. Now I will be left with a number which if it is still greater than 2, that means it's a prime. I have to so here now, after the 2 above loops are run, the number that I will be left with, if that is a prime number and is greater than 2, then the number will not become 1 by the above 2 steps. So to take care of this case, I have to append the leftover number to my prime factors list. So here number, if the number is still greater than 2, leftover number, that is note that the number has been adjusted all this while. Here the number was getting divided by 2, so it was getting reduced. Now in the next while loop it was getting divided by this I, so at each step it is getting reduced. So now after the 2 while loops, this number, if it is still greater than 2, that means if it's a prime and I have to add it. Prime factors dot int number. I should include an int here as well, and here. Really don't need there. All right, so now I have to return the final list. Return factors. Okay, now let's check the function print get factors 84. Just reformatting this file because there's some formatting issue. All right, let's run it. Cool, you can see that I have the same result here, but the second algorithm will definitely run almost twice as fast as my old version, because it is checking almost half, it is skipping almost half the steps by doing this. That is, the step is 2 here. I'm not checking each of the numbers across. All right, thank you for watching.